This data visualization plots 65 countries based on their technological advancement in 2023. As you can see, the Philippines sits at the bottom of the curve, resting at rank 63. Yet, contrast that baseline data with the country's aerospace outputs. The Philippine Space Agency operates the Diwata microsatellite program, capturing high-resolution environmental data from orbit. At the microscopic level, domestic biotech research yields similar breakthroughs. Filipino doctors successfully discovered the anti-cancer properties of lunasin, a peptide isolated directly from soybeans. We are looking at a stark discrepancy. The country produces individual scientific brilliance and engineers orbital satellites, but operates with severe friction in systemic digital competitiveness. To understand why this discrepancy exists, we have to look past the top-line ranking. We need to dissect the historical bottlenecks, measure the modern data deficit, and examine the highly targeted legislative workarounds currently in play. Deeply rooted economic friction, rather than a lack of national intellect, drives this low global ranking. We have to reverse engineer the system to see exactly where it stalls. Before European contact, indigenous societies in the archipelago executed sophisticated mathematical and engineering projects. The Banaway rice terraces required precise geometric planning and complex water management. Early shipbuilding techniques demonstrated a mastery of hull concavity to maximize sailing efficiency across the Pacific. Builders also utilized principles of ordinality, constructing boats specifically proportioned to fit inside one another for transport. During the Spanish colonial period, formal scientific institutions like the University of Santo Tomas were established, but their focus was strictly siloed. Research was heavily prioritized toward basic medicine, theology, and civil engineering for churches and bridges. The broader economy was structured entirely around the galleon trade. By concentrating wealth in the transit of foreign goods, domestic agriculture and local industrial development were deliberately sidelined. The American colonial era brought a more organized approach, with the creation of the Bureau of Science in 1901. However, research remained restricted primarily to tropical diseases, food processing, and agriculture. American free trade policies kept the post-Commonwealth economy heavily anchored to raw material exports. The nation was completely bypassed by the 20th century boom in heavy industrial manufacturing. Centuries of colonial economic structuring hardwired a macroeconomic ceiling into the nation, isolating the Philippines from the 20th century industrial technology base. That historical industrial stagnation cascaded directly into a modern, measurable structural deficit. This line graph compares domestic investment in research and development. In 2013, Philippine R&D spending flatlined at exactly 0.14% of its GDP, a stark contrast to the sharply rising average curve of its ASEAN neighbors. This severe lack of central funding fractures the retention of top talent. Without capital, there is limited collaboration between domestic industries and academia, leaving researchers with few local avenues to commercialize their work. This bar chart illustrates the STEM human capital crisis. By 2025, the country faces massive shortages, starting with a 13,000 personnel deficit in life sciences. As the chart expands vertically, the engineering sector reveals a highly disproportionate deficit of 569,000 professionals, towering over all other fields. This shortage of 500,000 engineers creates a destructive feedback loop. Without engineers, infrastructural upgrades stall. Without modern infrastructure, the remaining talent is economically forced to migrate abroad. The 63rd global ranking is mathematically correlated to that 0.14% investment rate and the missing 569,000 engineers. You cannot innovate without capital and creators. Faced with these macroeconomic constraints, the national response shifted away from brute force spending toward asymmetric, decentralized legislative strategies. The initial attempts to centralize science policy began with the National Science and Technology Authority during the Marcos administration, prioritizing energy and agricultural programs. The critical turning point occurred under Corazon Aquino. She elevated the agency to cabinet-level status, creating the Department of Science and Technology, or DOST, granting it the political authority to execute long-term initiatives. This map shows the DOST spatial strategy. Establishing nicer hubs decentralized research away from the capital, placing R&D tags into regional zones. Zooming in, the Davao region reveals a halal goat R&D hub, while Cagayan Valley focuses on smart water infrastructure and citrus research. To populate these regional hubs, the government deployed a human capital strategy known as the Balik Scientist Act. Republic Act 11035 legally incentivizes and funds the repatriation of diaspora Filipino scientists. This hexagonal graphic breaks down the rigorous evaluation criteria required for those returning scientists. Success is measured through the 6 Ps: generating new publications, patents, products, people services, places, and policies. By establishing regional innovation hubs and actively importing expert talent through targeted laws, the DOST engineered a decentralized survival mechanism to bypass the national funding drought. When properly shielded by these laws, this decentralized ecosystem yields highly specific, world-class technological outputs. The Biofuels Act of 2006 successfully mandated the extraction of bioethanol from local agricultural waste, utilizing NEPA sap and sugarcane to offset foreign energy imports. In 2019, the establishment of the Philippine Space Agency rapidly consolidated disparate research efforts, transitioning the country away from a strict reliance on foreign satellites toward domestic production. This led to the progression from the Diwata microsatellites to the Maya nanosatellites, and ultimately the student-led development of the Tala hybrid rocket, building local aerospace expertise from the ground up. The 63rd place ranking now serves as the measurable floor for these legislative interventions. Foundational policies, like the Magna Carta for science and technology personnel, remain the required bedrock for maintaining this momentum, granting critical incentives to the remaining local workforce. However, the ultimate success of this decentralized network depends entirely on solving the structural math. The government must close the 569,000 engineering gap and aggressively push R&D spending toward the ASEAN average. The legal architecture and the intellectual capacity for a Philippine knowledge economy are fully operational. Escaping the bottom tier of global innovation is now purely a matter of capital velocity and execution.